Hello everyone, welcome back to part 4 of the lesson. Before we start into class, we will actually have a recap on the history of the metals. Hope you have enjoyed the video on aluminum can manufacturing and also the history of cans. So in the next slide, we will look at the history of cans all the way from 1948 to current. So you can see that for all these aluminum cans, they are actually manufactured by the draw and wall iron method, which we learned in the third method previously. In short, it's called DWI, and it is actually a method of soda can manufacture. So you will see that for current aluminum cans, it is not only much lighter than the previous old steel or steel and aluminum can, but it is also more corrosion resistant, able to chill quickly, and has a glossy surface which is easily imprintable and eye-catching, and prolongs shelf life, and also very easy to recycle. The modern method for making aluminium beverage cans is called two-piece drawing and wall, which we have learned earlier. The next slide we will talk about the packaging standards of metals, which we have not talked about previously. So there are actually a few packaging standards which are actually for your own information only. So you have the good manufacturing practice that is actually to ensure quality assurance and also ensure that all the food contact materials and articles are consistently controlled to ensure that it conforms to the rules and quality standards. And also you have the steel packaging industry that also develops its own voluntary good manufacturing practice guidelines. The second packaging standards will be the European standards, which is the standard EN10333, the composition of the base steel used for the production of tin plate, and also the other will be the standards EN10335, which is the metallic coating used for the manufacture of lacquered ECCS. For this, if you are interested to know more, you can Google and I'm sure you will be able to find more of the packaging standards. So without any further ado, we will actually go on to glass, which is another type of packaging methods that we always see for packaging our food. So for glass, we will firstly start from the history of glass packaging, and an example will be the Coca-Cola chronology. From 1894, they have used glass all the way to 1975, as you see from the picture here. So this is just an interesting article that was found for 1916, where the birth of the contour bottle was for the Coca-Cola bottle, and it is actually because they were actually worried of the imitation of the straight-sided Coca-Cola bottle, so they actually designed the root glass company and introduced it in 1916, so it became one of the few packages ever granted trademark status by the US Patent Office. So today, I'm sure you have seen it before. It is really recognizable, and even in the dark, you could be able to see it. It is also very strong and very sturdy if you have actually drank and hold one before. So let's look at what are the constituents of glass. So glass is actually an amorphous inorganic product which actually fuse many different compounds together, and then it will be cooled so that it is actually having a rigid condition without crystallizing. Glass is also often transparent, and it is actually widespread, practical, technological, and decorative usage and packaging materials of many types of foods. So the most familiar and historical oldest types of glass are based on chemical compounds, which is silica, which is shown here, which is crystalline silica, and it is in the form of quartz. And when you heat it to very high temperature, where it melts, it will become random and forms amorphous silica, which is glass. We will talk about crystalline and amorphous in the next slide, so you can see the difference between amorphous and crystalline. And then at this high temperature where it has melted, it will be suddenly cooled down, and then additives such as sodium, calcium, and magnesium will be added in, and thus it will actually form a very tough glass. In the next slide, we will look at the differences between amorphous and crystalline. Amorphous and crystalline has differences. If you look at the diagram over here, amorphous, you can see that it is actually very random, not packed properly, and very disorganized. For crystalline solid, it is actually packed in a very regular way, and it is also repeated in 3 dimensions. So some examples of amorphous solid will be gel, glass, and plastic, while some examples of crystalline solids will be sodium chloride and quartz. So you now can see the difference, where amorphous is random, disordered, and crystalline will be structured and packed very neatly. For glass, we will actually have different constituents of glass. Different constituents will actually make up glass. So silica would be the main ingredient, and then you have soda ash, you have limestone, you also have colorants, you have alumina, and you have waste glass. So you will see that for soda lime glass, there's actually majority of silica, some sodium oxide, calcium oxide, and also some lime and other minor additives. So you will see that alumina actually has the advantage of improving chemical durability, removes gas bubbles, and reduce the time and temperature required for melting. A very clear and durable quartz glass can be made from pure silica. The other compounds are used to improve temperature workability of the product so that it can go through high and low variations of temperature changes. In the next slide, we will look at the manufacturing of glass bottle. So this is also for your own information. So an example would be press and blow and blow and blow. So there are 2 different types of making. So one is for the glass jar and one is for the glass bottle. So you can see the flow where they will actually put the silica inside, and then you will plunge it and you press it, and then you will have the shape, and then you transfer out, you blow it to the bigger shape, and then you will finally get your finalized jar. And for the glass bottle, you drop it into the mold, then you form the neck first, then you have blow it up to become bigger, and then you will transfer it to a blow mold, and then you get the final shape, and you will get the final finished bottle. If you are more interested to know, there will be this pre-reading, post-reading, where you actually find out more about how the glass bottle is made. It is an interesting process, so please look at the YouTube video for your post-reading. And with that, we end part 4 of the e-learning, and please complete your worksheets for part 4. Thanks for your time.